In this video, we want to use the Riemann sum definition of a definite integral in order to find the exact value of this definite integral. So let's rewrite this integral. So the integral from 2 to 5 of x minus 5 dx into Riemann notation. So that's the limit as n goes to infinity of the sum from k equals 1 to n of f of xk delta x. Alright, so I'm going to come over here to the side. We're going to know that xk, that's a plus k times delta x, where a is the start of our interval, so that's 2 plus k times, and delta x, that was b minus a divided by the number of rectangles, so that's going to be 5 minus 2 divided by n, which is 3 over n. And so delta x here becomes 3 over n. So in a condensed way, I could say this is 2 plus 3k over n. So if I think about that, and I'm just going to write out all my steps. So I'm going to just write this again in function notation. 2 plus 3k over n times 3 over n. I got to think about it like that. All that is inside the summation. So now I'm going to substitute this in here for x in my formula. So the limit as n goes to infinity of the sum of k equals 1 to n of 2 plus 3k over n minus 5 and then all of that times 3 over n. So if I simplify that, I get the limit as n goes to infinity of the sum of k equals 1 to n of 2 minus 5, so that's negative 3, and the 3k, so that's 3k over n minus 3 times 3 over n. Alright, so I'm going to move this to another page. Okay, so we've got it on a nice clean page, so let's continue. So we got the limit as n goes to infinity of the sum of k equals 1 to n. And so if we expand this out, we get 9k over n squared minus 9 over n. Okay. Now one thing to note here is in the summation is in terms of k. The only term that is in terms of k is that first term. So this is actually this term right here. This term right here is actually treated like a constant. So if we expand out this summation, and we say the sum from k equals 1 to n of 9k over n squared minus the sum k equals 1 to n of 9 over n, then this first sum is actually in terms of k. So I can think about that as the limit. I really should say the limit of all this, so this should be in square brackets, as n goes to infinity, is the same thing as 1 over n squared times the sum k equals 1 to n. Actually, I can bring out the 9 too. So that it's just in terms of k minus, and I can bring out that 9 over n, sum k equals 1 to n of just 1. Alright, and so from here we're going to use our sum rules. So the sum of k's, we know that to be n times n plus 1 over 2. and the sum of 1's n times is just n. So if we make those substitutions, this becomes the limit as n goes to infinity of 9 over n squared times n plus 1 over 2 minus 9 over n times n. And so this is the first sum, and that's the second one. If we simplify that a little, we get the limit as n goes to infinity. Let's expand out the top of this right here. That's going to give us 9n squared plus 9n over 2n squared. And then these n's are going to cancel, so I'm just going to have minus 9. And so using our limit rules, we see that this first term right here has a horizontal asymptote at 9 over 2, the ratio of the leading coefficients. So evaluating that limit is going to give us 9 halves, and then the limit of constants is just 9, and that's going to give us negative 9 halves, or negative 4.5. And so that would be the value of the integral. So we can say the integral from 2 to 5 of x minus 5 dx is equal to negative 9 halves.